Last class we discussed about lecture number 2.4. That as I told you, 2.3 we skipped. Inshallah, this Wednesday we will discuss lecture 2.3, and we will continue with 2.4. Inshallah, today. There is a problem with Zoom meeting. We have to finish within 30 minutes. There is a time limit, so I'll be going a bit faster. Like, we'll give you a brief explanation of this presentation. After that, you can read it. If you have any doubts, you can again ask in comments of that Google Classroom. Inshallah, 1 minute. Still, there are 2 more people. I think 100% attendance now. Not 100%. Still 2 left. Just 2. Okay. So we will continue with lecture number 2.4. What we discussed was about the first thing was what are the parameters to be considered when you design a power line. Actually, this continuation from 2.3, as I told you. So we have to consider the active power, distance, cost, safety, and easiness of installation. Then, based on that, when you design a transmission line, first you must know what are the main parts of a transmission line. Once you know the parts, then only you can design it. For what are the main elements of the transmission line. Again, in between, sorry, I'm giving a permission for new members. Okay, except one, all are here. Are we able to hear now? Okay. Hello, please, all of you able to hear me? Able to see the screen?
Yes.
Okay. Yes. Okay. In between, I have to admit newcomers. That's why some disturbance in between. Okay, now almost are here. Just one left. All others are here. So last class we discussed the main components. There are 5 main components: line conductor, then line insulator, support, protective devices, voltage regulating devices. Just I gave you a brief introduction about what are they. Today we are going to study this in detail. Starting from the first one, that was line conductor. As we discussed, this is the most important part, which allow current to flow. Actually, other parts are to help line conductors. Line conductors allow the current to flow or the power to transfer power from one, that is from the power plant to the substation. So when you take line conductors, you have to consider some parameters. Here we are again going for the design of line conductors. So when you select a line conductor, the parameters which you have to select are, first thing is a conductor. So to be a conductor, it must be, first thing you have to consider is high electrical conductivity. Like high conductivity materials, which is the highest conductivity material, gold. But we cannot go for gold because of the third condition, low cost. You have to consider cost. You have to consider conductivity. So a low cost, high conductivity material you have to consider. Not only cost and conductivity. Next thing is the mechanical strength, tensile strength. It must be strong. Otherwise, when you make the tower and line, it will break. So there must be 3 main things: conductivity, mechanical strength, then the cost must be low. Along with that, there are a few more conditions. That is, one is the specific gravity. That means weight. You can have strength, more strength, but if it is to get more strength, if you increase weight, the size of the tower must be big. So it cannot handle that such high weight. So we have to try for the materials which have low weight, or that is low specific gravity. Another important term which you have to consider is corona loss. Inshallah, another lecture we will discuss about corona, and also about local conditions, like some places where, like we have these chemical industries. The places where you have chemical industries, you have to use some special conductors. But normal, you can go for normal conductors like aluminum. So normally, all the line conductors, after considering all these parameters, most or almost all conductors are made of aluminum or its alloys. These are the two materials used. And these conductors or these aluminum conductors, when you make, it is not made as one thick conductor. Instead, it will be made as stranded conductors. I think you can see this pointer, right? Are you able to see the
Yes.
pointer?
Yes. Yes. Yes.
It is a pink one. Okay. So the conductors used, power lines, are aluminum. Also, these aluminum conductors are not made as a thick conductor, but it is made as stranded. Means now, alhamdulillah, all are here. We got 100% attendance now. Okay. So power lines will be stranded, means many small conductors will be put together, twisted to make as a conductor. It is to get higher flexibility. If you have a thick conductor, if you bend, it will break. But if it is many small put together, twisted, you can easily bend it. That is, you will get higher flexibility, also higher mechanical strength. So this wire, when you make the strand, there are different types of wires available, like you see in 221, different wire gauges. Depending on different wire gauges, there may be 6 strands, 12 strands, 18 strands, 24 strands, like this. And also for transmission purpose, because of high cost, we are not using copper. Copper is a good conductor, but copper is used only for the house wiring, etc. But for transmission, we are using aluminum conductors. And this aluminum conductors itself, we have 4 types of aluminum conductors used for making transmission line. One is all aluminum conductor. That means it is made of fully aluminum. It is normally used for secondary distribution, the last part. Also used in primary distribution in some areas. Then one of the most commonly used, 90% of transmission lines are aluminum conductor steel reinforced. Aluminum conductor steel reinforced means it is made of aluminum, but inside that aluminum there will be some steel to increase strength. Inshallah, next slide we are going to study about that. Third type is all aluminum alloy conductor. Instead of aluminum, we will use aluminum alloy. Alloy means it is mostly aluminum. Inside to aluminum, we will add a little bit of other materials so that its weight will decrease and strength will increase. Like the difference between iron and steel. Iron is not strong. It is almost yellow in color. But steel, we make steel from iron by adding some sulfur, some carbon, and few more some other materials into steel or to iron. Then it will become steel, and steel will be stronger. So this is the difference between a normal material and an alloy. We are adding a little bit, small percentage, 1% or less than 1% of some other components into that. Then its property will completely change. So aluminum is not that stronger. To increase the strength of aluminum, we can add some additional devices, but its cost will be more. So we are not using it that much. But under special conditions, we will use aluminum alloy conductor. And there is a fourth one, rarely used, aluminum conductor alloy reinforced. You will use aluminum conductor mixed with some aluminum alloy conductors. Okay, we will go to the aluminum conductor steel reinforced, because this is the most important. This is the one which is used for most of the transmission lines. So here, as I told you, aluminum conductor is mostly used, and it is mixed with some steel conductors to give more strength. You can see this picture. This picture. You can see all these white conductors are aluminum, and inside you can see some steel. This dark gray hashed ones or the gray ones are made of steel. So steel will give you strength, Aluminum will give you good conductivity. So it will be a stronger, high conductivity conductor. So why we go for that? We have some advantages. As I told you, there is high tensile strength and good conductivity. Tensile strength means mechanical strength. If the mechanical strength is more, the distance between the towers can be increased. You can make it tight. If it was not strong, when you make tight, or if the distance between the tower is more, it will break. Now it is stronger. You can increase the distance between two towers. That's what is called increased span. Span is the distance between two towers. If you increase the distance between two towers from one position to another, to one location, Yambu to Medina, number of towers required will be reduced, because you will be, if you are using smaller span, you need more number of towers. If you use longer spans, number of towers will be reduced. So number of supports required is reduced. These are the advantages. But there is few disadvantage. Main disadvantage is steel. The steel wires, it's difficult to make joint, not like aluminum. So because of steel, it is difficult to make splice, means joint. To make joint, as well as dead end means the last tower you have to make a tie it. So this will be a problem for ACSR. Also, there is problem of corrosion. I hope you know what is corrosion. This iron piece, something if you put in the ground, after a few days, it will damage, right? Aluminum not damaging, but steel will damage. That damage is called corrosion. So this corrosion chance is more for ACSR conductors. And coming to the application, as I told you, this is the most commonly used conductor for transmission. Almost all transmission and sub-transmission are using ACSR conductors, and very rarely used in primary distribution. Why it is not used in distribution and part is, in distribution number of joints will be more, and ACSR conductor is difficult to make joint. This is the first component, conductor. I'm going a little bit fast because we have time limits. The second component is line support. We discussed the last class. Line support is that tower which is to provide the support. So there are mainly three uses for line support. One is to keep proper spacing between the conductors. You know the tower shape. There will be tower and there will be arms like this. So this arm is to provide the distance between, one line will be this side, other line will be this side. So there is a proper distance between the lines. If two lines are closer, there will be flash, arc will happen between the lines. So the line must be at proper distance. So the arms of the tower will give you this distance between the lines. That is the one application, one use. Keep proper spacing between conductors. Second one, keep conductors at prescribed distance from its grounded parts. There will be some grounded, like if there is another tower or another building or this type of some grounded parts, if it is there, to keep proper distance from that grounded part, we are using line supports. And there is another most important part, that is maintain specified ground clearance, the height from ground. We have this must be a safety is one of the important parameter when you design a transmission line. So it must be high, proper height from ground. Height from ground is called ground clearance. So these are the three main application or uses of line supports. And what are the properties required for the main requirements of a line support? Of course, the first thing, high mechanical strength. It must be strong enough to carry this transmission line. If there is wind comes or any accident happens, this should not fall down. It must be mechanically strong. Second thing, light in weight. Even though it is mechanical strong, its weight must be less so that it will be easier to construct. Another one, cheap in cost. You have to use low cost materials, not cheap, but without compromising safety, strength, etc. You must use the proper material of cheapest, lowest cost. Again, longer life is important. You are investing a lot of money to make transmission line, so it must withstand for a longer life, and easy accessibility of conductors for maintenance. If something happened to the transmission line, you have to climb over the tower, so there must be some facility for climbing over the tower. These are the 5 main requirements of a line support. Now we will see what are the different types of supports. Maybe you might have seen, until now I was talking to you about towers, but support is not only tower. One type of support is tower. Support is first divided into 2. One is poles, other is towers. Pole is used for distribution, not for transmission. Like you see in these pictures, there are 3 types of poles used. One is made of wood. Maybe, I don't know, nowadays you see it or not, but in some villages you may see, some places, some students told me still in their place they saw this. This is made of wood. Long wood will be taken, suitable line, but as you know, this wooden strength will be not that good, so the span will be less. But there is a big advantage. The advantage is wood is a natural insulating material. Wood cannot pass electricity, so if you touch here, it's not a big deal because already it is wood and it is safe. But strength is less, and nowadays it is difficult to get such good wood quality, wood of straight and this size. So nowadays what we use is either concrete poles or steel poles. Here mostly what you see will be steel poles like this, something similar to what you see the street lights, same, made of steel, and through which transmission lines will be going. You may see, if you go outside, in Royal Commission it's difficult to see, but outside you can see this type of towers, and some places even this will be made of concrete. This shape is made of concrete, cheaper than steel pole. Steel pole main problem is it is costly, also it need maintenance expense is more, proper painting is required, otherwise it will damage. But it will provide longer span because it will be more stronger than concrete, so it will give you more span, so cost will be reduced. Second type of support, as I told you, it is towers. That is the one which you normally see, like you see in this picture. These are the towers. So this is used for high voltage and extra high voltage lines, that is transmission purpose. They have large mechanical loadings, it will be stronger, mechanically strong, and installation cost will be some higher considerable value. Normally it is made of steel only. There is no wooden, no concrete. Towers will be made of steel. And that towers, we are not going to the details of that, just to the types. Towers are mainly classified into 2: self-supporting type, stayed or guide towers. Stayed, normally you may not see that. It is something like this. It will have a narrow base and this line. These are some cables. Both sides it will be tied with the cable so that it is not falling down. So it is, if without that cable, if you put it, it will fall down. From both sides, using the cables, it is tied like you see here. This cable and this cable, it is tied from both sides so that it will stay straight. But self-supporting towers will be like this with the bigger legs. So no need of cable. It will stay like this, the normal one which you see. And that is, hello? Are you able to hear? Hello?
Yes.
Okay. And self-supporting, again, there are 2 types: wide-based towers and narrow-based towers. Wide-based towers, can you see this picture where I mark? You see one base here,
Yes,
another base here,
yes, yes.
another base here. All the 4 bases have 4 different concrete shapes. They are far, like bigger than our classroom, maybe the size of our classroom. That much distance will be there between these legs. From here to here, it will be like 10 meters. Such width is there. It's not small. But narrow base, you can see this is close. All these 4 legs are placed in a single concrete base. One base, narrow, like normally which you see for the mobile towers. Mobile towers are not narrow type. That size will be less. That is narrow based. If it is bigger, it will be wide based towers. These are the 4 or 2 types of self-supporting and 2 types of stayed or guide towers are portal type and V type. Portal type will be like this, like a pie, and V type will be like V. These are the types of supporting towers. So this first 2 we finish, conductor, then second is support. Third main component is line insulator. Line insulator, the function of line insulator is insulate line conductors from ground and each other. That is, this is the line insulator. So this is the line. This line you cannot directly connect to this tower. If you can directly connect to this tower is made of steel, so that it will become a short circuit. So to insulate is the first job of an insulator. Also, it support and anchor conductors. Actually, this insulator is the one which support this line. Holding, support means holding. It is holding the line. So that holding is one function, and other is insulate the conductor. So these are the 2 functions, and normally line insulators are made of either porcelain or a toughened glass or polymers like mentioned here. I'm going a bit faster because almost we are about to finish the time, only 5 minutes left. And what are the requirements of line insulator? You can read through it. Mechanical strength is required because it has to hold. Then it must provide high insulation. Insulation properties required. Dielectric strength is again about insulation. Then it must be non-porous, means there should not be any holes, because if there is hole, water will go inside and its insulation will be reduced. And it must be free from impurities and cracks. It should not be broken and should not be affected by changes in temperature. Coming to the type of insulator, mainly there are 4 types of insulator. From the picture, it's clear. Pin type, like this, like a pin. Post type, like a post. Suspension type, I will show you next picture. And the strain type, like this, which you see here. This is horizontal. Suspension type will be vertical. This is suspension type, and this is strain type. Both are same, made of small pieces, a chain made of small insulators, but when it is hanging down, it is suspension type. When it's horizontal, it is called strain type. And strain type is used only in these 3 places. All other places we will use suspension type. And the suspension type insulator advantages, you can read through it. Just if you have doubt, inshallah, you can ask next class. Coming to a few more small components, I will go through it. You can, one sentence, you can read it. Clamps, the one which is used for connecting the conductor to the insulating string. This is the clamp which you see here. This is the line conductor coming, and this is the insulator. This connection is done with the help of this clamp. That is the use of clamp. Second is damper. Damper is a shape like this. When you travel outside, if you go outside transmission line, if you see, you can see a shape like this. This is used to reduce the vibration. When the wind comes, line will vibrate. To reduce that vibration, there will be some weight hanged on it, so that if it cannot vibrate much. So the one which is used to reduce vibration is called damper. Then the ground wire. This is the top line which you see here. This wire is called ground wire. This ground wire is to protect from lightning. When the lightning comes, this conductor, all the lightning will be coming from top, right? From bottom we protected. We need to protection from top, from lightning, not light, lightning, thunder. When it comes, it should not hit this transmission line. Before that, it will be taken by this tower. So this, not tower, this ground wire. So to protect from lightning, we will use a open conductor on the top of the tower, that is called ground wire. Remember, it is made of steel and it does not carry any current. It is connected to ground, no current, zero voltage. And that's all about today's lecture.